The idea is that they're pulling answers from different universes simultaneously. They don't even completely understand how this is working, but the amount of power in computing is incomprehensible. Today we're about to dive into one of the most mind-bending and transformative breakthroughs in modern science. If you thought that quantum computers were some distant possibility reserved for science fiction, think again. Quantum computing is here, and it's officially broken the rules of reality as we know it. In this video we'll explore how quantum computers are not only revolutionizing technology but are also fundamentally reshaping our understanding of the universe. The age of quantum computing has arrived, and it's bringing with it a slew of breakthroughs that defy the conventional laws of physics. We're talking about machines that can solve complex problems in mere seconds. Problems that would take traditional supercomputers thousands of years to process. But these aren't just speed bumps on the road to innovation. Quantum computers are challenging the very fabric of reality itself. Before we dive into what's going on, let's break it down. Quantum computing is based on the principles of quantum mechanics, the weird and mysterious laws that govern the behavior of particles at the smallest scales. Now, to truly understand what's happening, we need to grasp how different quantum computing is compared to classical computing. Classical computers, the kind most of us use every day, process information using bits, those familiar ones and zeros. A bit can be either on or off, a binary state that makes up the foundation of all digital processing. However, quantum computers use qubits, quantum bits, those mysterious particles that can exist in multiple states simultaneously. This phenomenon is known as superposition. Think about it like this. Imagine you have a coin and when you flip it, it lands in two places at once, heads and tails. In quantum computing, this is essentially what a qubit can do. It can represent both 1 and 0 at the same time, increasing computational power exponentially. This is where things start to get weird because our world, the one we experience every day, is not governed by these principles. It's governed by classical physics, where objects can only exist in one state at any given time. Now, this idea of superposition allows quantum computers to perform calculations that classical computers could never hope to accomplish. But it doesn't stop there. Enter entanglement. Entanglement is another quantum phenomenon that defies logic. When two qubits become entangled, the state of one qubit directly affects the state of the other, no matter how far apart they are. It's as if two particles are connected by some mysterious force, instantly communicating with each other across space and time. This is where quantum computers really begin to break the rules of reality. In a traditional computer, if you change the state of one bit, you're affecting only that bit. But in quantum computing, a change in one qubit can instantly affect another, even if they are light years apart. But why does this matter and why is it such a big deal? Well, quantum computing's power lies in its ability to perform massive amounts of calculations in parallel. While a classical computer processes one calculation at a time, a quantum computer can process thousands, millions, or even billions of calculations simultaneously. This creates an exponential leap in computing power, making it possible to solve incredibly complex problems in a fraction of the time. To give you a sense of the magnitude of this leap, let's talk about factorization. Factorization is the process of breaking down a number into its prime factors. For example, 15 can be factored into 3 and 5. Now, imagine a large number with hundreds of digits like a number used in modern cryptography. Classical computers would take millions of years to factor this number, making it nearly impossible to break current encryption methods. But a quantum computer, using algorithms like Shor's algorithm, can factor such a number in mere seconds. This means that quantum computers have the potential to break encryption methods that have been the foundation of cybersecurity for decades. Sensitive data, from online banking transactions to classified government communications, could be at risk. But that's not all. Quantum computers could also revolutionize fields like medicine, material science, and artificial intelligence. They could help us develop new drugs by simulating molecular structures at an unprecedented level of detail. They could help create new materials with exotic properties, opening the door to breakthroughs in energy storage, superconductivity, and more. In fact, there have already been some impressive demonstrations. In 2019, Google made headlines with their announcement of quantum supremacy. They claimed that their quantum computer, Sycamore, had completed a task that would take the world's most powerful supercomputer 10,000 years in just 200 seconds. While some scientists debated the true significance of this achievement, there's no denying that quantum computers are now capable of doing things that classical computers simply can't. However, while the potential of quantum computing is immense, we're still in the very early stages of this technology. Quantum computers are incredibly delicate, requiring extreme conditions to operate. They need to be kept at temperatures colder than outer space, and even the slightest disturbance can cause them to lose their quantum properties, a phenomenon known as decoherence. This makes scaling quantum computers up to a practical size a monumental challenge. Still, progress is being made. Companies like IBM, Microsoft, and Honeywell are all racing to build more powerful and stable quantum computers. In fact, just last year, researchers at the University of Chicago and Argonne National Laboratory announced they had developed a new quantum algorithm that could lead to a major breakthrough in quantum computing. This algorithm is designed to reduce errors in quantum calculations, one of the biggest challenges facing the field. So why does all of this matter? Why should we care about quantum computers breaking reality? The answer lies in the fact that quantum computers have the potential to revolutionize nearly every industry, not just in terms of speed and efficiency, but in fundamentally new ways of solving problems. Imagine being able to simulate the behavior of every molecule in a drug in real time, without relying on trial and error. Think about the possibilities in artificial intelligence, where quantum algorithms could allow machines to learn and adapt at an exponentially faster rate. But there's also a darker side to this quantum revolution. If quantum computers can break encryption so easily, what's stopping them from being used for malicious purposes? Cybersecurity experts are already warning that quantum hacking could become a major threat in the near future. In fact, governments and companies around the world are already working on developing quantum-resistant encryption methods to stay one step ahead of this new breed of computing. Then there's the question of whether quantum computing will lead to a new form of artificial intelligence. We already know that AI is evolving at a rapid pace, and quantum computing could accelerate that progress to an unimaginable speed. Some theorists even speculate that quantum computers could one day give rise to a superintelligent AI, one that is capable of solving problems and making decisions that are beyond human comprehension. This raises all sorts of ethical questions. What if such an AI becomes so powerful that it exceeds human control? What if it begins to shape reality itself, manipulating the very laws of physics to suit its needs? For now, we are still in the early stages of this quantum revolution. But it's clear that quantum computers are no longer just theoretical devices. They are breaking through barriers, challenging the fundamental principles of physics, and opening up new possibilities that we can only begin to imagine. The very nature of reality itself is being rewritten, and the implications of this are still unfolding. As quantum computing advances, it will continue to push the boundaries of what's possible. Who knows what other mysteries of the universe we will uncover as we harness this mind-boggling technology? The future is uncertain, but one thing is for sure: the quantum age is here, and reality as we know it will never be the same. In conclusion, it's official: quantum computers have broken reality. What happens next could change everything. Buckle up, because we're entering a new era, one where the laws of nature as we know them are being redefined. The only limits are the ones we impose. The possibilities are endless, but so are the challenges. Will we rise to meet them, or will we be left behind by the very technology we've created? Only time will tell.